I'm sure, introduce himself, but just to say he is the best practices chairman for the VoIP Security Alliance tells you an awful lot on its own. So let's see here. Dan, you are now becoming the presenter.
Okay. Thank you. Thank you, Steve, for having it. And you should see the slides now, correct?
Yep, you are up and presenting.
Okay, great. Well, it was great to hear Michael's perspective on this, and I'll give an advance point to say that, well, actually the VoIP Security Alliance does maintain a list of tools, and I'll have the URL here in a little bit. So to just sort of talk about what's going on here, what's happening, I am part of the Voice over IP Security Alliance. It's an organization formed back in 2005 to bring together people who are involved in the security industry and also in the voice over IP industry to kind of talk about what are the real threats and the real problems and also the real solutions. It was formed basically because there were a lot of security vendors running around saying, you know, VoIP is inherently insecure, it's the end of the world as we know it, but if you buy my box, I'll be safe. And there were a lot of VoIP vendors at the time running around sort of saying, it's all those security nutballs, it's really not a problem, don't worry, just be happy. And VoIP was trying to say, was formed to say there are real problems, but there are also real solutions. And so I'll talk a bit about that. I also was the creator and co-host of a podcast called Blue Box, the Voice over IP Security Podcast, which you can find at blueboxpodcast.com. And my co-host and I did about 3 years worth of shows and all sorts of information. We've been kind of quiet for the last year, and we may or may not start doing more shows, but it's out there with a lot of content and interviews around voice over IP security in general. As Steve indicated, I'm also a member of a company called Voxeo, which is based in Florida and provides a platform for automating phone and communications applications, developing apps from large-scale IVRs and conferencing systems to Facebook conferencing apps and kind of everything in between. So that's what we do, and I head up the marketing team for that organization. But the issues that we've certainly seen within the voice over IP security space or in the security space in general, you know, are certainly well known. I mean, privacy available, you can see things here. We've certainly seen these issues. The noise around voice over IP security has been quite prominent over the past several years. As Michael mentioned, the vishing and some of the phishing and the other pieces that voice over IP doesn't necessarily bring about itself, but it makes easier in many ways. And there's certainly also a good number of information in the larger security community. The SANS Institute, which puts out its top 20 security risks, has identified voice over IP as one of its top threats for the last couple of years. Now, this is also, I mean, to be fair, it's broad categories. I mean, Windows, Linux, things like that are also on the list. But it also just points to the heightened adoption of voice over IP in general. There's a lot of tools, not just, you know, the SIP Vicious and VoIPAC and the EEX Ping Poker that Michael mentioned, but a lot of other ones that are out there. And I'll have a link to, again, a list of a lot of the tools that are out there people need to be aware of. And what the Voice over IP Security Alliance did about, it's a couple years ago now, was we put out a list, in large part because people who were trying to defend their systems and test their systems weren't aware of what all the tools were. And so we put it out there so people could be able to know, because the reality is that the attackers know where the tools are and what they're doing. And so we want security professionals to be able to know what was there and how they could use the tools to help with testing their own systems and ensuring their security. There's a lot of books out now. There's actually even another one that I should put up on this list that I've been aware of lately. But there's a lot of good books that really go through how you can secure your VoIP networks. One in the middle there, the Hacking VoIP Exposed, you know, actually walks through Cisco, Avaya, Nortel, and Asterisk systems and talks about, you know, how you can attack those. And really, you know, attack and defend are just really, it depends upon the difference in the color of your hat, really. And so it's good. They're good information. You should be aware of them because the books are out there. People can read those and work them. The big challenge really in voice over IP is that the security of systems in the old days, in the world of TDM, the traditional PSTN, the traditional phone system, it was pretty simple. The security was there. You know, you just secured the switch, you kept people with butt sets and alligator clips away from the wiring, you changed the voicemail passwords, and generally you were pretty set. It was all in all a fairly simple matter. The problem is that with voice over IP security, it's a much more complex proposition. There's a lot of different components. It's no longer that you just simply call one vendor. There may be a range of vendors that you have to be involved with. And also, as you get into larger companies, you get a lot of finger pointing. You know, it's the firewall people or the server people, or you know, it's a lot of different people are involved in that. So it's not necessarily a clean and simple thing. It used to be you could just call somebody, call the vendor of the phone system, and they'd come in and do something. Well, now, you know, it's just sitting on a server somewhere, maybe under somebody's desk, and it's linking into everything else. You know, and especially in the case of Asterisk, it may not even have a specific owner, or it may or may not, depending upon who's, you know, the size of the organization and what's being involved with it. And that's really kind of the larger comment I'd make, is that as we move into what we call unified communications, whatever we want to refer to it as, it's all about an ecosystem of products. There have been a couple of alerts over the last couple of years where I remember one that was, it's now been a number of years, but there was one where there was a Rolodex application, basically, that when used improperly would cause an Asterisk system to crash. There was another one where if you were using basically a messaging store that was putting your voicemail messages into an IMAP mail system, if an improper message was sent in the correct way, it would wind up crashing your phone system, crashing Asterisk. So you get into these wacky things as we extend more and more capabilities into this larger communications, you know, mechanism, this system, where pieces that are on the edge may wind up impacting something like Asterisk. So it involves a lot more thinking around what are the pieces that are connected into your system, what are the pieces that are out there, and what do you have to worry about, you know, who are you, who's responsible for it, what are they doing there. So I will say, though, that I do believe that you can have more secure voice over IP than the PSTN if you do it properly. And that's the big if there, because there are capabilities. You know, I am talking to you on a teleworker set from an office in New Hampshire. It is going over a secure encrypted connection down to an office in Orlando, Florida, where my company's based, and then from there out to the PSTN. And it's going across secured connections and secured lines. But if it were not done that way, if somebody you know, had not known how to do that, it could be very insecure. So, but on the other hand, I have you know, I have an encrypted end-to-end connection, or at least end-to-gateway connection, which is more than I ever had on the public switch telephony network. So let's talk a little bit about security concerns in general. We've always had concerns in telephony. In history, we had, of course, the blue boxes, with the in-band signaling that would get you free long distance, etc. This is actually a picture from the Computer History Museum, and actually, a little bit of trivia, this is actually a blue box that was created by Steve Jobs and Steve Wozniak, but a little fun thing on there. We've also been trying to prevent these types of things. There was a product called the Hushaphone that was a silencer. You can see here, you would put it over the old candlestick phones, and you would have privacy, etc., and all these. So we've been trying to protect against these kinds of threats. When you look at what we have to be concerned about, we need to look at the media and the voice. Is kind of the most tangible one. We want to eavesdropping, etc. Call control, the public switch telephony network management side, and then the underlying network. And I want to talk about each a little bit. Before that, though, I think it is important to talk a little bit about how SIP works, because that's the open protocol that most folks are using for a lot of the communication, and how that sort of comes into play. In general, when you have two SIP phones, you have Alice calling Bob in the proverbial pattern here. You have SIP going from Alice's phone to a SIP proxy going to another proxy and then down to Bob. And then you often have the RTP, the voice media, streaming directly from Alice to Bob. Now, Asterisk changes this a bit, because Asterisk will have the RTP streaming into the media server in Asterisk. It will not necessarily stream directly from endpoint to endpoint. But this is the general flow that you see, and of course, this could be across an internet or WAN type of connection that you would have. So when we talk about media, the big concerns are certainly eavesdropping and degraded voice quality. You know, there was, when I was working at a previous company, I was involved with some security scans and some security, you know, analysis as you went into large-scale RFPs. And, you know, a security team at one point said, you know, if I'm pumping 20,000 packets a second on our local network, you know, the voice quality degrades. And I sort of said, well, yeah, but, you know, if there's 20,000 packets a second going on your network, there's a larger problem on that particular network segment than just the voice quality in some ways. So there's the typical kind of network things we need to think about. Packet filtering, virtual LANs. VLANs are not a, you know, they don't necessarily provide a overall solution, but they provide one mechanism of helping prioritize something like voice traffic over the other data traffic. And I mentioned encryption here. And encryption is, when implemented correctly, it doesn't solve all problems, but it solves a number of them and makes a number of other problems much harder. So it's certainly one way to go and do that. Encryption in the media, most people at this point are using something called secure RTP or SRTP, which is a quick and lightweight way to go and encrypt the RTP stream while also being extremely secure. And so you're seeing that happen out there. On the signaling side, you know, I was struck with comments Michael made about toll fraud, about impersonation, caller ID spoofing, all of those things. Call control, you know, signaling, especially in the SIP world. Now, this is not true exactly of EECS, but on the SIP side, you know, it's all in the clear. It's all like it's like email essentially. It's an HTTP-like protocol. It's all ASCII text, and so if you can intercept the call, if you can get in the middle of the call, you can certainly modify it in transit. So there are issues there that you need to that go back to needing to protect the integrity and the confidentiality of the signaling stream. There's also the availability issue, making sure that your SIP server is available and that there's some kind of alternate, you know, or availability that you've got redundant connections, whatever it may be, so somebody can't just go and launch an attack against your SIP endpoints or your SIP server and be able to take your network offline. Again, encryption is one mechanism. A lot of folks are using TLS encrypted SIP, which is SSL. So TLS, it's like SSL. TLS encrypted SIP is one way that people are doing this. There are people using IPsec for tunnels that just tunnel the whole thing. There's different theories around that and different elements. One issue with IPsec is that it often tends to be a bit heavyweight, and so you wind up creating a lot of extra traffic. One of the issues with SIP, and actually I shouldn't say SIP, with voice over IP in general, is that it has a lot of little tiny packets. So when you take, on the media side, when you're streaming media, you're generally chopping things up into very tiny little packets and sending those off. And so it can create a lot of overhead with some of the encryption techniques, which is why a lot of people use SRTP on that side. On the signaling side, a lot of folks are using TLS encrypted SIP. One challenge there is key exchange, is getting the encryption keys from one end to the other. And it in a single vendor environment, it can work well, but when you have multiple vendors, it can be a challenge. There's a couple solutions out there that people have looked at. One is from Phil Zimmerman, the ZRTP protocol that's been around. Another solution that the IETF, the Internet Engineering Task Force, is promoting is something called DTLS SRTP, which essentially is datagram TLS in the SRTP stream. So it's some things that are happening on that regard. I mentioned here encrypted phone software. There are challenges out there. A lot of the phone sets will go and load their software or check for updates using protocols like TFTP, the Trivial File Transfer Protocol, which just goes and downloads an image. And if you can get a phone, if the software is stored on a server locally, and if somebody can compromise that, it is possible to trick a phone into downloading software that would have some kind of rogue information in it that could potentially be, for instance, sending signaling back to another site or something like that. The management side is an interesting one because a lot of the phones, a lot of the IP phones, you know, they're not just little pieces of you know, equipment with buttons and lights on them. They're computers, and so they have, you know, services running on them. They have passwords, often default passwords that were used to provision the phones, and then people forget to go and change them. And you have to think of every little phone out there, every IP phone, as a computer. You have to think about it as, what are the default passwords? Have they been changed? Do you need to patch the phone systems or the phones themselves? What are they running? Are they running non-essential services? A few years back, Sean Merniger, a security researcher, did a look at Wi-Fi SIP handsets and found that some of them had SSH servers running on them for administration. A couple actually had a Telnet server running on it. One had a POP3 mail client. You know, all sorts of stuff that just doesn't need to be running on a phone per se. So you have to look at your endpoints, look at what's there, understand what the security risk may be. You also, you know, in this day of unified communications and creating this ecosystem of applications, we have a lot of application programming interfaces, APIs. And one of the questions is, who can access that? What kind of connections can be made to it? All of those different issues that you need to be thinking about it and understanding, again, what are the risk factors you need to look at. And management interfaces, who has that? The other issue is, you know, the public switch telephony network. Toll fraud, you know, as Michael mentioned, is an issue. It's probably the most expensive, the easiest, or the most expensive financial issue that we have, the security threat. And a lot of newer players out there, you know, are struggling to spell PSTN. They know about IP and they know how to work with that, but they don't understand, you know, what kind of connections or what would happen if you leave your, you know, voicemail open. You just use default passwords that people can easily go in and reprogram it to allow you to direct phone calls out onto the network. You know, it's a common issue that people have used out there. Another challenge with voice over IP, which is also its opportunity, is that there really, you know, are no geography issues, because I can be, as I said, up here in New Hampshire talking on a phone that is connected to a system down in Florida, and on from there. It's both a strength as well as a weakness. As Michael mentioned earlier, a number of folks, rather than having some kind of secure teleworker solution that would allow people to provision external phones, they would just put the IPPBX or whatever device directly out onto the public internet without any kind of hardening, without anything like that. So if you are going to do that and make use of remote workers, you need to be sure you have some kind of remote teleworker type of solution. Generally, they come in two flavors. Most of the teleworker solutions I've seen involve something that has a secure SIP connection, a TLS encrypted SIP connection, going back to some kind of server on the edge of the network, and then they're using SRTP again for connection back to, again, some device on the edge of a network. There are a few vendors out there who have gone and actually embedded an IPsec client into the phone itself, the IP phone, and they've gone and had that connect back there. And then when you talk about soft phones, again, it could be a soft phone either using direct connections from the soft phone software itself, or coming in over a VPN, an IPsec or PPTP or whatever VPN you are using on that. So things to think about in there. I want to spend a couple minutes just about SIP trunking, because it's a pretty incredible part of what people are using voice over IP for, to get the PSTN connectivity, because I can be running Asterisk or any software in my home, and I could be able to use SIP trunking to have PSTN connectivity out to the larger world. The challenge, of course, is if you're running that SIP trunk over the public internet to a SIP service provider, you are sending your call signaling, and potentially your media is all going across the internet in the clear if you're not looking at how to go and secure that. If you're using a carrier's network, the same network, for instance, that provides you with data or your internet connection, then very often, you know, they are a little bit more concerned about security, and so they will, because it's on their own network. But you're often paying a higher price to use their SIP connections. So you may typically be looking out across the public internet. So you have to be concerned. Now, I shouldn't say it's trivial to get to that connection, but it is not non-trivial. I mean, somebody who can get in between where your IPPBX is and where the SIP service provider is, who's somebody who can get in that path, can be able to see your call traffic and your media path. So in this era of compromised servers, botnets, all of those things, the potential's out there. You know, it may be challenging, but it may be there. One advantage of SIP trunking I'll mention is that you have a lot of capabilities for business continuity and disaster recovery, because from your one IPPBX, from your Asterisk box, you can connect up to multiple SIP service providers. And you could have a whole slew of them if you wanted to provide you with geographic redundancy and connectivity that could get you inbound or outbound calls, so that in the event that one of your SIP service providers went down, you would still have connectivity coming through other providers. I want to move on a bit. Cloud is all the buzz these days, and again, because we have this lack of geography, this doing away with the connectivity, and we can really do massively distributed networks these days where you can put some of your functionality on premise, you can have some of it up in a hosted environment, and some or all of that. You do have to think from a security point of view. You have to be thinking about, how do I secure this? If I have a local IP PBX that's connecting across the internet to some kind of application platform or some other hosted service and going out there, or if I'm using, all of my phones are local, my soft phones, and they're going out to some kind of hosted service, what's the security of the link between my on-premise devices and my hosted system? What does that look like? What's the security of the data? All of those different types of issues. And mostly a lot of it's availability. Can you trust that the cloud will be there? And I mentioned some questions here, and the slides will be available afterwards again as far as what kind of availability, geographic, network, physical redundancy, all of those questions. What are those? What's the security of what's out there? I want to finish kind of talking about the threats with spam, or SPIT as it's referred to, spam over internet telephony. And if you think about what a traditional telemarketer needs, the person needs for an IPP or a PBX, a phone connection, all of those. And there's a certain amount of latency, there's a certain amount of cost. Now, the challenge is as we move into into voice over IP, those costs go away for a large part. They can take Asterisk, they can run it on their home system, they can get some very cheap SIP trunk connectivity, and they can be able to go and make the connections out across the internet and make a lot of calls. As I say here, it makes for great headlines. It's not yet a significant threat. We're seeing it in certain places. And, the fear is that there's a tool that just goes and iterates through SIP calling addresses. And, in fact, on the list of tools that I'll show you, there is, in fact, one of these tools that will work with Asterisk to do precisely this, to go and do this kind of automated war dialing, basically. The general reality is that most companies do not allow direct SIP connections. Most of what's happening right now is that SIP chunking, SIP out on the internet even, is used for PSTN line replacement. So it's going, instead of installing PSTN direct connections into your office, you're using an IP connection out to a SIP service provider who's doing the PSTN connectivity for you. So the reality is that we're not generally having direct connections. But as people start to do more, as they start to federate, as they start to go and do that, and we get to the point where incoming calls are allowed from any other IP endpoint, as we get to that time, we have a larger challenge here, or will have those challenges if we aren't looking at ways to deal with this. Until then, the PSTN really serves as a firewall in many ways between us, which is kind of ironic. But anyway, what I mentioned before, the Voice over IP Security Alliance, we have a number of different projects. We have a mailing list, voipsa.org/voipsec. We have a blog, podcast. We have a document out there called the VoIP Security Threat Taxonomy that was created in about 4 years ago, October 2005. Sadly, it's still the same list of threats that are out there, but we created a document, a PDF you can go and download, which really lists the threats to voice over IP. We did that in large part because every vendor was running around with their own separate list of what the threats were, and so we wanted to have kind of a neutral one. I am charged with getting a best practice project underway, and at some point we'll be working with that a little bit more. I mentioned the list of tools. It's up here, voipsa.org/resources/tools.php. It's got a long list of tools that are out there with links to them that you can go and see. Not only the ones I put on the slide here, but there's a lot of other ones. Many of them, yes, are designed to work with Asterisk. And they do fall into a wide range, tools that will enumerate all the SIP endpoints. They're tools that will go and do fuzzing, do attacking of the SIP protocol or the EEX protocol. some of the other ones. There's also some interesting tools too. There's things that will go and if you can get to the point in the network where you're between the sender and the receiver, you can do things like intercept and modify the media stream, so that you could, for instance, mix in other background noises. So somebody is calling somebody and you mix in the sound of a dog barking or whatever other interesting sounds you want to go and do. And the ironic part about that attack is that the person calling, of course, has no idea because they don't hear it. It's just being mixed into the recipient's media stream. So there's all sorts of things that you could do if you can gain access to the stream. So they're out there. The tools list there. I mentioned some items here. I also mentioned a couple of other pieces. There's a document that the National Institute of Standards and Technology in the United States came out with. Well, it's about 4 years old, but it's still good. It's called Security Considerations for VoIP Systems, SP 800-58. And what it does is it provides a good tutorial on what some of the standard protocols are, SIP as well as the older H323, what the issues are, what you need to be thinking about as well. The other one I'll mention is network security tools. VoIP, with VoIP, voice is just bits across the wire. And so everything that you do in normal network security is now a concern that you need to be thinking about in terms of voice. I'll also mention the Hacking Exposed VoIP book, which I know the authors of, but not to be biased among books, but I know that they put this site up along with a number of tools, including some tools to do things like look at find IP phones using Google and other issues that are out there. So it's a site to take a look at as well. And I would again say that I think you can make VoIP more secure if you do it properly. And I will leave it right now to say, let's have some questions if there are any. And you can go to voipsa.org again. You're welcome to contact me as dan.york@voipsa.org. So back to you,
Thank
Steve.
you very much. Awesome. I've got a bunch of questions here, and we'll probably take 3 or 4 of them because we're running a little bit late, but that's fine. We got a lot of good information there. First, somebody asks, does changing your SIP port away from 5060 for external endpoints do much to increase security?
No. I mean,
yeah, it sort of struck me as the old security through obscurity thing, and it's not very obscure if you just move it a few numbers away.
Yeah, and then you're creating all sorts of headaches on your end to go and reconfigure all of your endpoints. And then you're also going to not be able to communicate with other people who want to communicate with you via SIP. And a scanner will find it anyway, and some probing will figure out that it's a SIP or something. So I would not do that.
Okay. Next, Joseph Burdick asks, are there established SIP trunking providers that provide SRTP or something besides open/clear media signaling?
Yes, there are a number. Increasingly, if you go and talk to some of the SIP service providers, they're at least aware of the issue. I queried a number. There was a panel at one of the conferences about 2 years ago, and there were 8 providers up on stage, and I asked them why they weren't doing it. And one of their comments was, well, because nobody's asking us, which was a cop-out in my opinion. But anyway, that was what they said. But there are a number of the larger providers, if you go and ask them, they will do that. There are also a number of smaller providers that I've seen talk about providing secure SIP and SRTP as a way of differentiating themselves. So they will give you secure connectivity. So there are certainly, I wouldn't limit yourself to looking at the larger players. I'd also look at some of the other smaller folks out there as well.
Excellent. One more question, and then we'll go on, I think, to our next presentation. But someone asks, how do we protect the phone conversation when using a provisioning server where the phones pick up their configurations, as in hosted PBX? So I'm not quite sure. Maybe that he's asking, how do you actually protect the provisioning session to make sure that nobody is basically sniffing information out during that process?
Yeah, and so if I thinking of what the person's asking, in many of the hosted environments, if you had an IP phone on your desk or something, it will have a local copy of its software that needs to start up, but then it will go and and check for a new copy, or some of them may just boot entirely off of an image it downloads from a provisioning server. And so that goes back to the question I mentioned in there as far as, I would ask your vendors around what are they doing in terms of, I know some of the vendors use encrypted software loads. So in the provisioning server, the phone will go and download it, and it will download it, but it's been securely both encrypted and digitally signed so that the phone knows that it has not been tampered with, and will load that up and be able to use that software load. Now the other aspect though, so that's getting the software on there. I know some environments also have phones that have the software all loaded, but then they go and they connect to a server to download the information of what extension they are, what what's their caller ID, all the different pieces that are part of things, what their SIP gateway is. And on those, again, I would be talking to the provider about what is the security of that session. Is there, is it TLS encrypted? Is there something? What is it? How is it downloading that configuration data down to the phone? It can be done securely, but the question is really, is the vendor doing that?
All right, very good. Well, I think it's time to go on. I appreciate, Dan, all the information that you presented with us, and I'll be putting your presentation up along with Michael's at the end of this presentation so that everyone has access to it. But thank you very much for joining us.
Thanks for having me.